Alright, and welcome to Multiplying Imaginary and Radical Numbers. And here I'm going to try and give you kind of the same or similar imaginary, same or similar radicals, and I want to show you kind of the distinctions here. So what is 5i times 6i? And with all things, I want you to really break this down into parts. So for example, what is 5 times 6? Well, that's 30. And what is I times I? Well guys, notice I still has an exponent of 1, I has an exponent of 1, and when we multiply these things together, we are going to add their exponents. So I times I becomes I squared, much like x times x becomes x squared. Now this is actually a curious case. Alright, we have 30i squared, but I want you all to kind of remember the letter I is actually equal to the square root of -1. So we could actually do a little substitution here. We could say this is 30 times the square root of -1 squared. And what do we know happens to a square and a square root? Well, they cancel. So this is actually like saying 30 times -1. Now as a sidebar, one thing, here, and let's finish this first. And what is 30 times -1? Well, it's -30, okay? So 5i times 6i is actually -30. So here's our first kind of unique property. When you multiply two imaginary numbers, you actually get a real number, albeit a negative number. Now one other thing, from this point forward, whenever we see an I squared, like an I times I gives us I squared, I will always just simply cross it out and put a negative, or a sign change. Why is that? Because I squared is essentially -1, and all that does is change the sign. Okay. Now this brings us to our example 2, which I think now you might have an idea of how to solve. 5 square roots of 2 times 6 square roots of 2. We're essentially multiplying these by parts. 5 times 6 will give us 30, and the square root of 2 times the square root of 2 is really the square root of 2 squared. But my question is, what happens to a square root and a square? Well, they cancel, they're opposites. This is really saying 30 times 2. We know 30 times 2 is 60. So 5 square roots of 2 times 6 square roots of 2 is 60. Of all the things that we learned today, I think this is going to be the most difficult one. I would really encourage you to keep watching the video, see all the examples, and really perfect this before moving on. Okay, here for example 2a, we have -8i times 4i. Well, of course, remember, we're going to do -8 times 4, which will give us -32, and I times I, which will give us I squared. Now you'll recall I squared, I want y'all to remember this is an identity. I squared is actually equal to -1, so I cross that out and I simply change the sign. A negative becomes a positive. -8i times 4i is equal to 32. Alright, let's move on to example 2b. Here we have -8 square roots of 3 times 4 square roots of 3. So what is -8 times 4? Well, that would be -32. And the square root of 3 times the square root of 3 is really the square root of 3 squared. Okay, we know that square roots and squares cancel, so this is really -32 times 3. And -32 times 3 will actually give us -96. So this simplifies to -96. Alright, let's move on. Okay. Here's our last example where we're going to talk about imaginary numbers. So what do we have here? We have -25i squared times 8i. So can we multiply the i's when they're not the same? We know that we cannot add them, but yes, we can multiply. This is really an I to the 1. Now guys, what's -25 times 8? That's of course going to be, -200. And I squared times I to the 1 is really I to the 3rd power. Now there are a number of ways that we could reduce I cubed to make it look different, but I'm simply going to leave it like this because for the scope of our lesson we're not really concerned with how I cubed simplifies. Okay, let's talk about example 3b. Now here we have -25 times the square root of 5 times 3 square roots of 2. So wait a second. We know that we could not add these because they have different numbers inside the radical. However, can we multiply them? Well, of course we can. So we do the outside times the outside, -25 times 3. In fact, let me use different colors here. -25 times 3 will give us negative 75. And then here, we know that the square root of 5 times the square root of 2 will actually give us the square root of 10. So you can think of multiplying radicals as we multiply the outsides, and we also multiply the insides. Now I want to show y'all one final example. So let's go ahead, pause, finish taking your notes. Let's move on. Okay, here's our final example. Example 4, we have 3 square roots of 6 times 4 square roots of 8. And in fact, let's make it even more interesting. Let's make that a negative 3. Well, we know our rule for multiplying radicals is the outside times the outside. And so negative 3 times 4 will give us negative 12. Square roots of, now we multiply the inside times the inside. 6 times 8 is 48. However, you'll notice this can actually be reduced. And so we still are accountable for simplifying here. 48 breaks down into 4 and 12. Of course, if you felt more comfortable, you could have done 2 and 24. Y'all could have done 8 and 6. It doesn't really matter, but let's break it down. We know 4 breaks down into 2 and 2. 12 breaks down into 2 and 6. And 6 breaks down into 2 and 3. Of course, this is a square root, so we're looking for groups of 2. So I circle my group of 2 there. I circle my group of 2 there. And I notice that my 3 is the only left over. Now, what in the world will this look like? We know that we originally had a negative 12 on the outside, times, but we have this 2 that has a partner, so it gets to escape, times this 2 that has a partner, so it gets to escape. And then we still write square roots of our last number, 3. Now from here, it's just some simple addition. We know that negative 12, let me use blue again. Negative 12 times 2 is negative 24 times 2 square roots of 3. Negative 24 times 2 is negative 48 square roots of 3. And there is our actual answer, negative 48 square roots of 3. All right, I'll see y'all in our next video.